This video, we're going to use reference angles to find the exact values of the expression. It's very similar to what we did last time using coterminal angles, but it's a little different in that the angles that we're going to get here may end up in any quadrant, not just in the first quadrant. So let me draw a little diagram for you first here to help you know what signs we're going to have for the 6 trig functions and various quadrants here. So I say to myself, all students take calculus. Other people say things like add sugar to coffee. The A stands for all 6 trig functions are positive there. Sine and its reciprocal cosecant are positive here. Everything else is negative. T is for tangent and its reciprocal cotangent are positive in quadrant 3. Everything else is negative. And C stands for cosine and its reciprocal secant. All the other 4 are negative in quadrant 4. So again, A for all 6 are positive in quadrant 1. Sine and cosecant are positive in quadrant 2. All other 4 are negative. Tangent and cotangent are positive in quadrant 3. Everything else is negative. Cosine and secant are positive in quadrant 4. Everything else is negative. When we talk about a reference angle, we're talking about the acute angle, meaning that it's between 0 and 90 degrees, that is made with the positive or negative x-axis. So I'll draw a picture for you each time so that you can see where we are. For instance, in the first problem, problem 10, 405 degrees, we've gone more than 360 degrees, and we've gone another 45 degrees. So our reference angle is 45 degrees, and this sine of 405 degrees, since we are in quadrant 1, is equal to a positive sine of 45 degrees is the square root of 2 over 2. Number 11, the tangent of 750 degrees. So we're going to go 360, 720, and another 30 to get to 750. So this is the same as tangent of 30 degrees, which is going to be 1 over root 3, which is root 3 over 3. Hopefully we get 1 or 2 outside of quadrant 1, otherwise this won't be very interesting. Cosecant, so we've got 360 and 90 is 450, and another 90 is 540, and another 60 is 500. So 500 degrees is down there. Now we've got one that's in quadrant 3. So 60 degrees is my reference angle, and cosecant is going to be negative in quadrant 3. So I'm going to say that this is a negative cosecant of 60 degrees. Is going to be the same thing as cosecant of 600 degrees. So this is going to be a negative. And I'm going to look at the 60-degree angle here in quadrant 1. It's going to be root 3 here, 1 here, and 2 here for my reference angle. So cosecant is hypotenuse over opposite. And I'm going to rationalize. like so. So I just looked again for what is the angle between the x-axis and the terminal side, which was 60 degrees. I drew that 60-degree reference angle in quadrant 1 using my reference triangles, and I picked the appropriate sine using the chart here. Because cosecant is related to sine, it would only be positive in quadrants 1 and 2. I'm in quadrant 3, so it's going to have a negative value there. Let's try cotangent of 570 degrees. So that's going to be 360, 450, 540, and another 30. So we have a 30-degree reference angle. Now cotangent is going to be positive in quadrant 3. So this is going to be the same thing as the tangent, I'm sorry, the cotangent of 30 degrees. And 1 root 3, 2. So cotangent of 30 degrees is root 3 over 1 is root 3. Let's clear those and we'll start talking about some angles that are in radians. So sine of 5 pi over 3. We're not quite to 2 pi because 2 pi, if I look at it over 3, is 6 pi over 3. So I'm pi over 3 away. This around this way was 5 pi over 3. So I'm in quadrant 4, and sine is going to be negative there. It's negative sine of pi over 3. Pi over 3 has a sine value of root 3 over 2. Now let's look at tangent of 7 pi over 6. 7 over 6 is a little bit bigger than 1, so there's 1 pi, and another pi over 6 is there. Pi over 6 is equivalent to 30 degrees, so I have a pi over 6 reference angle. Pi over 6, pi over 3. This is 1 root 3, 2. I am in a quadrant where tangent is positive, so this is equal to tangent of pi over 6 is going to be equal to 1 over root 3 is root 3 over 3. Now we have tangent of negative 3 pi over 4. If you know your even odd identities, you can pull that negative out. But let's go ahead and let's just look and see what quadrant I'm in here. So negative 1 pi over 4, 2 pi over 4, negative 3 pi over 4. I'm down here in quadrant 3 where tangent is positive. My reference angle here with the x-axis is pi over 4. So this is equal to tangent of pi over 4, which is going to be 1. Now let's look at cosecant of 4 pi over 3. Again, we're a little bit bigger than pi, 1 and another third. So that's 60-degree reference angle, or pi over 3 reference angle right there. Cosecant is related to sine. Sine is positive in quadrants 1 and 2. So this is the negative cosecant of pi over 3. And let's look at my reference triangle, pi over 3, pi over 6, pi over 2. This is 1, this is root 3, and this is 2. Cosecant is the reciprocal of sine. So that's 2 over root 3, which we would rationalize and make that negative 2 root 3 over 3. Now let's try secant of 3 pi over 4. So 1, 2, 3 pi over 4 is over here in quadrant 2. Cosine is going to be negative there, so secant is also going to be negative. It's negative secant of pi over 4, because pi over 4 is my reference angle here. And we're going to look at that 45, 45, 90, or pi over 4, pi over 4, pi over 2 reference triangle. And the secant value is square root of 2. Last problem for this section is going to be cotangent of negative 11 pi over 6. Again, if you know what to do with this negative from your even odd identities, go ahead and do that. But I'm just going to look at this as that's not quite negative 2. So I haven't quite gone all the way around like this. I'm left with pi over 6 there, and that is my reference angle. So this is the same thing as cotangent of pi over 6. If I look at that reference triangle, we have pi over 6 down here, pi over 3 there, and this is 1 root 3 and 2, and my cotangent is adjacent over opposite, which is going to give me root 3. So that's it for this. I'll see you next time for the next section of videos.